Okay, welcome to Introduction to Data Science class. This is our first lectures for R. As we said earlier, most of all the assignments will be in R. So again, this is our first lectures. So in these lectures, we are going to cover Introduction to R, which is again the basic concept. As we defined previously in our lectures, what is a data science? Again, it's a multidisciplinary field. Consists of at least a knowledge of mathematics such as linear algebra, matrix, the list keep going, database system, AI. Also data science use mostly machine learning algorithms. So the knowledge of machine learning algorithms also is very important. So here we say data science is an exciting discipline that allows you to turn raw data into understanding, insight, and also knowledge. So the goal of data science again is trying to gain some knowledge or find a pattern in a large data set. So the goal of R for data science is to explore the most important tools in R that will allow you to do data science. So we know R consists of so many packages that make it possible for us to, again, apply the tools on the analysis of data or data science task. So what we're going to learn is, first, we know data science is a huge field, as we said earlier, and also it's an interdisciplinary field. So there's no way that a person can master data science concept by reading a single textbook or even by taking a single class. So most of the time, data science is very difficult to get one textbook that may cover everything. Because, for example, we should know what machine learning algorithms, and we have to know what tools to use, whether Python and R. We also need the concept of database management system, how data is organized, how data is stored. And in computer science, these are all different field of studies. So our model of tools needed in a typical data science project may look something like what we have here. So first we say, again, in the theory, we use different terms of the stages of data science life cycle or data analysis life cycle, the stages. For example, we say first we can start with coming up with planning and objective. And then we get the data. We have to prepare the data, which is data preparation, both transformation and normalization of the data. Then we apply the model. We do the data science task. Then later we evaluate our output, the result, or interpret the result. So the same concept in this diagram. Import means the first thing we have to do is to get our data. We have to import our data. The second step, which is called the tidying. Tidying means we have to prepare our data preparation. Maybe the format of the data, we have to have it organized. And also transform concept is doing normalization of the data. Then after that, we visualize our data. After visualization of the data, visualization of data always make us to understand the concept, the content of our data. If there's any pattern in the data, we may see it through visualization of the data. Then after that, we build our model by applying machine learning algorithm, etc. Then the result we get, we have to communicate. So we can say that the terms are a little bit different, but it's the same as what we cover in our lectures on data science and also data mining. We say data mining or knowledge discovery in data. The process we start with getting the data, integration of the data, which is next data preparation, transformation, normalization. Then we apply the model. then we evaluate our result or interpret the result. So the steps are again almost the same, similar. So first, we always import our data, as we said. So using R, we have to import our data into R. If we can't get the data into R, then we cannot do any work. We cannot do data science or data mining or data analysis. So the main menu for data science is having the data. Then once we import the data, it's a good idea also to tidy it. Tidy means, again, storing the data in a consistent form. The semantics, matching the semantics of the data set, and the format, how the data is organized, etc. So in brief, when your data is tidied, each column is a variable and each row is an observation. Observation will be the record. So what we mean is that, for example, I have a record of one customer. The variable, the column of the variable, or the variable will be, let's say, last name, first name, address. Now, the row, which is observation, means one record of the customer. So customer may have more than one column or one variable. Sometimes we use the term field. So tidying data is important because the consistent structure lets you focus your struggle on questions about the data. And here we say not fighting to get the data into a right form for different functions. So we know that even in data mining, the data preparation process can take over 60 to 80% of all the data mining tasks. The same thing applies to data science also. So tidying data means preparing the data for the tasks for analysis. So once you have tied the data, the common first step is to transform it. So transformation includes narrowing in on observation of interest. So here, for example, in theory, we mentioned about principal component analysis. This is an algorithm that we can use to reduce, if possible, to reduce the data. And the process is called transformation or resampling. And here, like, excuse me, like all people in one city or all data from the last year. So we can create in a new variable that are functions of existing variables. Example is like computing speed from distance and time, or calculating a set of summary statistics, such as the mean, median, mode, etc. Now, together with tidying, which is preparation of the data and also transforming the data, we use the term wrangling. Wrangling is used a lot in data science, data wrangling or data mugging. So those are the two terms also. So when we say data wrangling or data mugging, we mean preparing the data, both tidying and transforming of the data right before we move to the next stage of analyzing the data. So once you have the tidying data with variables you need, now there are two main engines of knowledge generation. Excuse me. So we can do visualization and also modeling. These are the most common steps. Most of the time, for example, in data mining, we can skip visualization and do modeling straight. Modeling means applying the algorithm or mathematical formula into your data. But visualization is very important too, because again, sometimes we can visualize the data and we can find a pattern in the data. So visualization is a fundamentally human activity. A good visualization will show you things that you did not expect or raise a new question by the data. Again, easily raise a new question by that. So visualization, we said a picture worth more than 1,000 words. If I have a data set and it's in a test data set, hardly before you can find a pattern on it. But if you plot a graph or you visualize the data, most likely, let's say a scatter plot with only two attributes, we can find out if there's a relationship between the two attributes. So a good visualization might also hint that you are asking the wrong question or you need to collect different data. And also visualization can surprise you, but don't scale particularly well because they require a human to interpret them. Models are normally something that we always have to do. So the concept of models is now applying the machine learning algorithm into your data, a data that is already well prepared to get some knowledge. So models are complementary tools to visualization. Once you have made your questions sufficiently precise, you can use a model to answer them. So models are fundamentally mathematically or computationally too. So they are generally, again, scale well. Example of a model can be a classification model or supervising. And these classification are different algorithms that we can use to, again, classify data. Communication is the last step. So when we get after modeling, we get the result, we have to communicate our results to maybe the management or the project stakeholders, etc. So the last step of data science is communication, an absolutely critical part of any data analysis project. So it doesn't matter how well your models or your visualization have led you to understand the data, unless you can, again, communicate your result to others. So in this lectures here, again, as we said, the steps are the same. Data analysis life cycle stages. We start with the planning, the project or the objective. Then after that, we need to get our data. Then we need to prepare the data for analysis. Then we move for modeling and visualization. Then we come up with the result, interpret the result. The same steps apply here also. So programming is a very important tool as a data scientist or data analysis. But again, you don't have to be an expert programmer. At least the general knowledge is enough. So here we say you don't need to be an expert programmer to be a data scientist. But learning more about programming pays off, because becoming a better programmer allows you to automate common tasks. So as a good programmer, we can put any task or any process into a computational algorithm or write a code, automate it. So that will lead us to our tool that we're going to study today, R2. So R is one of the special tools for a data scientist. It's a very good tool for data analysis. And the main reason why, first, it's free. Everybody can get access to it. And also it has so many packages, which means so many library files, the web built-in packages for analysis data. We also have a Python. So most data science, the most common tools is the R and also Python. So here to download the R, we go to the, we go to the R, go to the CRAN, which is the R Archive Network, Comprehensive R Archive Network. And the website is given down here. If we haven't yet downloaded it, you can go to this website and download it. After you download the R, it's a good idea also to download the RStudio. RStudio is more like an IDE, integrated development environment, because the RStudio have both the output screen. In one window, we may see the output screen, we may see the console and Explorer, etc. So RStudio is an IDE So we need to download it. So this is how the interface of the RStudio looks like. At the bottom here, we have our console. So this is where we're going to enter most of our command. And also it said going. So we have some menus here. Most of the commands that we can perform by writing the command. We can also use the menu also. Very simple example. If I want to build, I have a function, I want to build it, or if I want to install a package, I can use the menu to install my package, or I can write a code for storing package. And also on the right side here, we can see, for example, I enter some few items here. So I can see the objects that are used or the variables, what kind of operations I perform to show. Also, if I have a graph, graph also may show down, we can see the plot. So when I plot a graph, I can view the plot on this area, lower right side. So in this course, I'm going to give an assignment this week. In the assignment, we are going to use the tidyverse. Tidyverse is a R package, and it comes with a data set and also a functions that we can use to do examples of a data science task. So here we say we also need to store some R packages. The R package is a collection of functions, data, and documentation that extend the capabilities of base R. So if I want to perform the same thing also in Python, we have the packages for data science, like NumPy, scikit-learn, that's machine learning algorithm packages. The same thing applies to R also. So using packages is the key to successful use of R, because R have a lot of packages. So majority of the packages that you will learn in this course are part of so-called a tidyverse. So how do we install? And also I would advise everybody to install this. You can follow the steps and download your R, then download your RStudio, then start the RStudio. You see an interface on the left lower side. You see at the console prompt, just start install.packages and then tidyverse. Again, this will install our tidyverse. We're going to use this package in this course from now on. So I wrote down here on your own computer, tap the line of the code in the console, and then you download the package. Now, if you have a problem installing, then make sure you are connected to the internet. That's your computer you are using is connected to the internet. And also this website, this is the website that most of the R packages are. It's not blocked by your browser or your firewall or the proxy. So make sure the website is not blocked. So this is the tidyverse. One thing we should know is that anytime we install, so the first step here, we're going to use the command install.packages tidyverse, or if you have a RStudio also, we can install package using the menu. Now, after that, in order to use the tidyverse package, you have to load it. And we normally load a package into our workspace by using the function name library. So after you install the packages tidyverse, then you come here and say library tidyverse. You may see some messages like this saying, again, most of the functions data is loading. So here we say you will not be able to use functions, objects, and app files in a package until you load it. Even after you install it, first step install, When you install finish, you are going to load it using the library function. So once you have installed a package, as in the previous slide, we installed a tidyverse, we have to use the library function to load it. Now look the difference. When we are installing, we make the tidyverse as a string. So double quotation in the argument. But in the next slide, when we are loading it, the tidyverse doesn't have no double quotation. So these are some few small things that you may end up getting error. Also, we have other packages, but beginning we are going to use the tidyverse. After that, throughout the course, we are going to use 3 more packages. We can see those packages. So if you like, we can install the packages. So now if you want to install more than one package, you can use the C function. So here I want to install the New York City flights 13. These are also a data, then Gapminder, then Layman. So here I want to install 3 different packages. I can install it individually, but again, we can use the C function, which is right here, C function, to install all of them. So here we say there are many other excellent packages that are not part of the tidyverse because they solve problems in a different domain or are designed with different set of underlying principles. So as you tackle more data science projects with R, you will learn new packages and new ways of thinking about data. So in this course, we will use the 3 packages from outside the tidyverse, which are the 3 packages here. These packages provide data on airlines. So the first one is New York's NYC flights, 13, airline flights. That's the data. Then the world development. And also we have the baseball that we use to illustrate key data science ideas. Again, make sure you install this package. Later on, we are going to use it for lab work and also homework assignment. So our overview, we said that in the prompt, we may see the right arrow. So here we say that you can enter command once at a time at the command prompt, the right arrow, or run set of command from a source file. Also, there's a wide variety of data types, including vectors, numerical, character, logical, matrices, data frames, and lists. We may go through this if time permits. So again, I'll give the lectures on it. I will try and make a video on it for sure. So to quit R, we use the Q function or quit function. We can also, if you are using RStudio, we can also use our menu to exit if you want to close the program or exit from the program. So most functionalities is provided through the built-in and user-created functions. And all the data objects are kept in memory. So basic functions are variable by default, and other functions are contained in a package that can be attached to current sections as needed. So when we start our R, we get our R interface, the console. We can type the command. Here I'm using RStudio. So on my lower, I can see the right arrow right on my lower left side. I'm ready. Actually, beginning, I've already entered some few items. I enter x equal to 0, column 9. 0, column 9 means I'm creating an object or a variable. In R, we use the term variable as object. And I'm trying to assign values 0 to 9. So 0, column 9 means values from 0 to 9, which is like 0, 1, 2, 3, 4. So if I like, I can type X and press enter, and it will tell me what values are in X. Here I want to know the data type of 0 to 9. As we said earlier, we have integer, decimal, Boolean, numeric, etc. So when I'm going to assign a value to a variable or an object, I can use the left arrow no space, left arrow and a dash. Or you can just use the assignment operator. And we're going to try and do some examples soon. One thing also we should know is that R is a case sensitive. Case sensitive means if I enter uppercase X and lowercase x, they are two different objects. So these are some examples. So first, we use C, which is the C function 1:10, which means we are assigning values from 1 to 10 to X. Then you have a condition saying that if S is greater than 8 or S is less than 9, so this will be a condition. Sorry, S is greater than 8 and S is less than 5. So greater than 8 means I'll get 9 and 10. Less than 5 means I'll get 1, 2, 3, 4. So this means I need a range of the values 1, 2, 3, 4, 9, and 10. Because S is already from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But by using this, I'm assigning different values now. So here, the same thing, we have the CS to 10, 1:10. If I type X, I may get all the values 1 to 10. Now I have a condition saying that is S greater than 8, which means I'm going to check is 1 greater than 8, no, so it's false. 2 greater than 8, no. So you see we get false throughout. Then when we reach 9 greater than 8, yes, so it's true. 10 greater than 8, yes, it's true. So we're going to get 8 falses and 2 truths. 9 and 10 is greater than 8. Same thing, I have S is less than 5. So it's 1 less than 5 here, 2, 3, up to 4. 4 is less than 5. The next is 5. Is 5 less than 5? No. 6, 7, 8, they are all false. So again, you can give a try on this. And also I'm going to try some soon. Here we have a ls means when I create an object and I want to see the list of my objects, I can use the ls function. And here I create only 2 objects, S and Y. I can separately use again assignment operator or equal sign to assign values to objects. And again, these are some few examples. So what I want to do now is to go to the R and then try some few programs. As we said, R is a case sensitive. So uppercase F 00 or 00 is different from uppercase F lowercase 00. So this will be the conclusion, but before that, I'm going to start my R program here. Again, this is my RStudio. So I can enter any value. Again, when you start the program, let me cross it. So I'll go to start and I'll look for my R program. I'm going to use the RStudio. Then always at the console, this is where you start to enter your command. So let's say I'm going to create an object named X, as we said earlier, and I'm going to assign 10 to it. I'm using the equal sign. Now, when I press X, it will tell me the content, which is 10. Now I can use class X, which will tell me the type of data. Here, the data is a numeric. It's a numeric data. Now we saw that I can change the value to, let's say, I'll use the C, and I'll say 1 to 10. The C should be lowercase. And now when I enter, again, my variable is lowercase x. So for example, if I enter uppercase x, it will not recognize it. I have error. So I enter lowercase x, it will tell me all the values from 1 to 10. And also we can use this as a calculation. So I can say 4 plus 3, it should give, 4 plus 3, it should give me 7, or 34 divided by 8, it will give me 4.25. So I can use it for multiplication too. Multiplication is the same as asterisk. So 6 times 2 is 12. So any arithmetic operation. We can even use it for trigonometry. Let's say sine 2. We have some few values. I want to copy and paste them. So here I have again, it can be any sine value, but I'm just want to, so I have sine 9 divided by 75, and it should give me the answer. Now, if I want to know the answer, I have to enter the x again, and I will see the answer 0.005 something. And what I will say is that, again, we can practice the homework assignment. Also, our textbook have a lot of questions, and I may go through the questions tomorrow when we meet in live chat, the assignment I gave last week. So let me do one more command here. Here I have y is log s plus s times 2. I already have x value. X value is 0.00, so this will work. Now, if I don't have no variable for x, it will not work, so it works good. Now, I want to know the answer, so I type y again, and it gives me the answer to be negative 5.2 something, etc. So we are going to end somewhere here. Again, the main objective of these lectures is to get the concept of R. We start with the R program, but the main thing is that I'm not going to focus on how to use the R for general programming, like how to write a function, the loops, the beginning, or the data types or data forms, etc. As time goes on, we may pick them one at a time. But this course is focused on data science. So we are going to use the R to do data science tasks. But as time goes on, we're going to pick the main concept of our, the features of our, like different types of data, how functions are written, etc. So again, wish everybody the best, and I'm going to end here.